This video tutorial will take a look at factoring quadratic expressions. The first polynomial we will factor is x squared plus 10x plus 21. This polynomial is quadratic because it is in the form ax squared plus bx plus c. In this particular example, we have an a value of 1. This is going to make our factoring of this quadratic expression quite a bit easier. When starting to factor any polynomial, we must ask ourselves the question if it has a greatest common factor or not, which this quadratic expression does not. Generally, when factoring a quadratic expression, our factors will be two binomials as shown. We just have to determine what our terms are in each binomial. We know that when we multiply the first term of each binomial, it will get us our first term of our quadratic expression. So, in this instance, because our first term is x squared, the first term in each binomial must be x. This will be true in every example where the a value is 1 in a quadratic expression. Now we just have to figure out the second term in each binomial. We know that the second terms, when multiplied, will equal the final term in our quadratic expression. So these could equal 7 and 3, or 21 and 1. These final terms in each binomial must add up to be the b value of our quadratic expression, which in this example is positive 10. So 21 and 1 would not work, but 7 and 3 would work. So these would be our two factors of this quadratic expression, x plus 7 and x plus 3. Let's check for accuracy. X times x would be x squared. X times positive 3 would be positive 3x. Positive 7 times x would be positive 7x. And positive 7 times positive 3 would be positive 21. We can combine positive 3x and positive 7x to make positive 10x. So as we see, our factors x plus 7 and x plus 3 check out. Let's review again how we've determined the second term in each of our factors. Positive 7 and positive 3 had to multiply to get to be positive 21, and they had to add to get positive 10, and it's highlighted in red why this has to be the case. So the factors of this quadratic expression are x plus 7 and x plus 3. Let's try a second example. Let's factor the quadratic expression x squared plus 6x minus 16. This is a quadratic expression because it is in the form ax squared plus bx plus c. We do not have an a value showing because it is 1. Again, we must first ask ourselves the question if we have a greatest common factor, which we do not for this quadratic expression. So, our quadratic expression will factor as two binomials. We know when we have an a value of 1, as in this quadratic expression, the first term in each factor will be x. As demonstrated in the first example, the second term in each factor must multiply to get negative 16 and add to get positive 6. Let's start by thinking about the various options that could multiply to get negative 16. Negative 4 and 4, negative 16 and 1, and negative 1 and 16, negative 8 and 2, and 8 and negative 2. 8 and negative 2 would be the only of these options that multiply to get to negative 16 and add to get to positive 6. Therefore, these become our second terms in our factors. It's important the value of each. We have positive 8, so that has to go in as plus 8, and negative 2, so that goes in as minus 2. So we have our two factors, x plus 8 and x minus 2. Let's check for accuracy. X times x is x squared. X times negative 2 is negative 2x. Positive 8 times x is positive 8x. And positive 8 times negative 2 is negative 16. We can combine negative 2x and positive 8x to be positive 6x. So our factors check out. X plus 8 and x minus 2 would be the factors of this quadratic expression. Let's try another example, x squared minus 5x minus 24. This is also a quadratic expression because it is in the form ax squared plus bx plus c. We do not see our a value because it is 1, as with the other examples in this video. Again, we need to ask ourselves the question first and foremost if there is a greatest common factor, which there is not for this quadratic expression. So, as is the case with most quadratic expressions, our factors will be two binomials. The first term in each factor will be x. The second two terms must multiply to get negative 24 and add to get negative 5. Let's begin listing out our options that can multiply to get negative 24. Negative 24 and 1, and negative 1 and 24. 12 and negative 2, and negative 12 and 2. Negative 8 and 3, and negative 3 and 8. Here we can see that negative 8 and 3 will be the options that multiply to get negative 24 and add to get negative 5. So these become the second terms in our factors. Again, it's important to recognize the value. Negative 8 has to be put in as minus 8, and 3 has to be put in as plus 3. So we have our factors, x minus 8 and x plus 3. Let's check for accuracy. X times x is x squared. X times positive 3 is positive 3x. Negative 8 times x is negative 8x. And negative 8 times positive 3 is negative 24. We can combine positive 3x and negative 8x to be negative 5x. So our factors check out. X minus 8 and x plus 3 would be our two factors. Let's try one final example. Let's factor the quadratic expression x squared minus 10x plus 9. We know it's a quadratic expression because it's in the form ax squared plus bx plus c. We do not have an a value showing because it is 1. Again, this quadratic expression does not have a greatest common factor. We will factor this quadratic expression with the factors being two binomials. The first term in each factor will be x. The second term in each factor must multiply to get positive 9 and add to be negative 10. These two numbers must be negative 9 and negative 1, because when multiplied they will get positive 9, and when added they will get negative 10. So our two factors are x minus 9 and x minus 1. Checking for accuracy, x times x is x squared. X times negative 1 is negative 1x, or negative x. Negative 9 times x is negative 9x. And negative 9 times negative 1 is positive 9. Negative x and negative 9x can be combined to make negative 10x. So our factors check out. The factors of this quadratic expression are x minus 9 and x minus 1. Let's do a quick recap and look at all the different quadratic expressions we factored. All of them were quadratic expressions because they were in the form ax squared plus bx plus c. All of these expressions had an a value of 1, so we do not actually see it, we just see x squared. Because of this, in each example, the first term of each factor is x, as shown in red. Now shown in red, the second term of each factor had to multiply to get the c value, or the final number in the quadratic expression. And the second term in each factor must add to get our b value, which is now highlighted in red.